Welcome back once again to CCSD Earth Science. I am your host, Mr. Miller. Today we're starting our weather unit. So this is our introduction to weather. And the weather is what is taking place outside right now. Okay? When we predict weather, yes, we're doing a weather prediction. But when we're talking about weather, we want to know what the current conditions are right at that time. Okay? Now, all weather occurs in the troposphere. The troposphere is the lowest part of the atmosphere. Okay? Now, for example, you can see the clouds out in the sky. Well, sometimes when those clouds are way off in the distance, you can see the tops of the clouds, and the tops of the clouds are flat. Well, that flat part right there is the top of the troposphere. That's where the other layer of the atmosphere comes in. So all the weather that affects us pretty much takes place in the troposphere. That's where all water vapor is, and we'll talk about that in a later section. Okay? Now, meteorology is exactly the study of weather. So, meteorologist is somebody that studies the weather and, does our weather forecasts and stuff like that typically. Okay? Now, to cover this unit, we need to know a lot of different weather instruments. Some of these instruments you are very familiar with, I'm sure. A thermometer, for example. A thermometer is going to measure your temperature. It could be in Fahrenheit, it could be in degrees Celsius, or it could be in degrees Kelvin. Okay? For example, this thermometer right here. Okay? This thermometer, trying to get the glare off it for you guys, but this thermometer is showing Fahrenheit on the very outside of it. Okay? It is 68 degrees Fahrenheit. Well, that looks like it's just about, I can't quite see it closely, but it looks like it's about 20 degrees Celsius. Maybe 19, I can't tell from this distance, but that's about what it looks like on this thermometer. Okay, so this one measures Fahrenheit and Celsius. There is also a Kelvin measurement, but we typically use Kelvin when we're talking about absolute zero, because absolute zero, 0 Kelvin, is when all molecules stop. Okay, something that has not been able to be reached. Okay, a Sling Psychrometer. A Sling Psychrometer measures the dry bulb and the wet bulb temperature, which are measurements of the air in essence. The air temperature is directly the dry bulb. So that measurement that I just showed you guys, that's the dry bulb temperature. However, with a Sling Psychrometer, right here is a Sling Psychrometer, and this instrument right here has a handle on it, right down here, that allows it to spin. Okay? And then it has the two thermometers. The dry bulb of the thermometer is this top one. It's dry. It has nothing on it. Well, the wet bulb of the thermometer has a sock on it. Now, the dry bulb temperature never is going to change even as this thing spins around in the air, because the air wind speed does not affect the temperature. It affects what we know as the wind chill. So in the middle of the winter when it's really cold out and the wind is blowing, we call that a wind chill, because what it's doing is it's evaporating the moisture that's on your skin, and so it makes it feel colder than it really is. Okay? But the wet bulb is kind of, in essence, the same idea as that wind chill, because what it's doing is as the water evaporates off this sock, it is going to take temperature away from the thermometer here. Okay? So it's going to make this temperature cooler. Okay? So what I'm going to do, and just show you these really quick here. What you do is you take and spin this, and the dry bulb temperature is not changing, like I said. But what's happening with the wet bulb temperature is the temperature is getting cooler because it's taking energy away from the thermometer relatively, and making it cooler to evaporate that water. Now, you can see that wet bulb temperature is dramatically cooler than the dry bulb temperature. Now, that happens when the air is really dry. When the air is dry, you're going to have a bigger difference between the dry bulb and the wet bulb temperature. Okay? We'll talk about this because you're going to use those two and the Earth Science Reference Table, the ESRT, to find dew point and relative humidity, which we'll talk about later. Oh, I did want to say, the dry bulb and the wet bulb temperatures are both measured in degrees Celsius, because when you go to the Earth Science Reference Tables, that's what you will need, is those temperatures in Celsius for the chart that we have. If you have a Fahrenheit temperature, there's nothing wrong with that, but we have to learn how to convert that temperature into Fahrenheit. from Fahrenheit into Celsius. Okay, now a barometer. A barometer measures the barometric pressure, or the air pressure, the weight of the air above you. Okay. For example, if you guys have ever driven down a relatively steep hill, like even going into Watertown down State Street Hill, if you know where I'm talking about, when you go from the top of that hill to the bottom of the hill, you're at two totally different elevations. When you're at the bottom, there's a lot more air above you. Okay? When you're at the top of the hill, there's not as much air above you. That is a difference of air pressure. Okay? That's what makes your ears pop. Okay? Same thing, flying in a plane does the same exact thing to you. Now, this is a barometer, and the barometer measures, if you can see on the outside there, it says inches. The middle says centimeters, and the inside says millibars. Well, we won't worry about the centimeters, but we're going to be doing the inches and the millibars when we do the video. I mean, when we do our measurements. Now, the inches, just labeled IN, and then in the millibars are just going to be MBs. Okay? But that, like I said, is the weight of the air above you. Now, the anemometer. An anemometer measures wind speed. The units are either going to be in knots or in miles an hour. Now, this is an anemometer that you might see on the top of a weather station with the cups, and it spins around on a stick, kind of. Okay? This is another type of anemometer. Okay? This one, in the very back of it here, which is tough for you guys to see, but maybe if I turn it that way a little bit, you can see it. But it has this little metal piece that comes down, and as this moves, rocks forward or back, okay, it will tell us what the wind speed is. So I'll just show you really quick. That's all that happens, and it shows you the wind speed. So the stronger the wind blows, the more it pushes that little metal bar, and yeah. Anyways, then we have a wind vane, okay? Wind vane measures the direction of the wind. Now what they do is they tell you what direction the wind is coming from. So if this one is pointing to the southeast here, we have a southeast wind. That means it's coming from the southeast. Okay, I can tell you right now, it's going to be a relatively warm air if it's coming from the south, because we have warm air to the south. So if it's coming from anywhere from the south, typically it's warmer air. If we're going to have colder air, it's going to come from the northeast. Okay, this right here does the same thing. It has a little compass on the top. So depending on how I turn this, okay, it will tell me the direction of the wind. Okay, now that's a wind vane. A lot of times you're going to have an anemometer and a wind vane all on a weather station itself. All right, last two things that we have here are a rain gauge and a hygrometer. Well, a rain gauge, just as it sounds, it's a gauge that measures the rain. Right here is a very accurate rain gauge, a relatively accurate rain gauge. We have one that actually measures to the hundredth of a centimeter of, hundredth of an inch of rain. Anyways, so this one, if you can see on the top, it shows in millimeters or inches. Well, I just put down here that we're just going to measure it in inches because that's all we will need to know. Yeah, you might in a profile map or something like that see it in centimeters or millimeters, but what we're going to measure it in is always going to be in inches. Okay, so it's the amount of rainfall that you get. Now I put rainfall because it does not measure the amount of snow we get, because when you get snow, if you get snowflakes that fall in here, you get an inch of snow, that's going to put it up here. Okay, but that's not equivalent to an inch of precipitation as in rain. Okay, it's not exactly an inch of water content. Okay, an inch of snow carries, if we took an inch of snow, put it in here, and melted it down, it's probably going to be way down here towards the bottom. Inch of snow doesn't really amount to that much moisture. Okay, but when you start talking feet, yeah, now you're starting to get a lot more precipitation. Okay, now, people usually put these in their gardens because if you don't get enough rain, then you will need to water your garden, water your flowers, water trees in your yard possibly. Okay, and then every once in a while it gets so dry that we have to kind of put a water ban out that in the village you can't water your lawns and your gardens and stuff like that because there's just not enough moisture in the ground, and that's why we use rain gauges to figure out how much moisture there really is out there. Okay? Now a hygrometer. A hygrometer is going to measure the humidity, which I know we haven't talked about humidity yet, but I think you guys have an idea of what humidity is. It's the moisture in the air. And so this is measuring how much moisture is in the air compared to how much it can hold, and that's in a percent. Now I'm going to go back to this instrument right here. This on the bottom of it has a hygrometer. And right now, okay, I just told you guys a minute ago it was about 68 degrees. Well, the hygrometer is saying we have 62 or 3% of the moisture that we could possibly hold. Well, it shows over here that it's in the normal range. Well, if it was up here, it would be in the high, okay, and humid, and over here it's in the dry. Okay, that's where we'll likely be inside in the winter. That's why people have a lot of skin problems, have to use a lot of moisturizer, because the hygrometer, or the moisture content, or the humidity gets very, very low in the winter. Because what we're doing is we're taking the air that might have some moisture outside, and then we bring that inside, and we put it at a different temperature, and now it doesn't hold as much moisture. Okay? The moisture content is a lot lower when it's inside. Warm air can hold a lot of moisture. That's why you get your humid days in the middle of the summer. Cold air doesn't hold as much moisture. That's why it's drier in the winter. Okay? So these are just some of the instruments that we're going to be using. One thing I do want to point out is a weather station, like our weather station on top of the roof of the school, pretty much measures all of these for us. It has each of these instruments on it. Okay, that's why weather stations are not typically cheap, because they do have a lot of accurate scientific weather instruments on them. Okay? Bring these notes with you to class, and we'll be checking them over for a grade.